Good morning. It's Monday, April 13th. Um, I was just grading your Path 205 Cliff Notes for the day, for the week, for last week, and quite a few of you skipped a particular problem, so I wanted to work it. So this is on Cliff Notes number 16, vertical tangent lines. I like this problem a lot because, it's actually from an old free response question. I don't remember the year, but we get to, where am I going? Here it is. I'd like to try to work this problem for you. Okay, consider the function defined by x, y squared minus x cubed y equals 6. Find the x coordinates where each point of the tangent line is vertical. So we have a vertical tangent line when the derivative, so imagine vertical line, we have a vertical tangent line. Oops, that's not what I want to do. We have a vertical tangent line when the derivative is undefined. So first we got to take the derivative. So first we're going to have product rule. So we have first times the derivative of the second, 2y dy dx. Oops, hold on. Let me try this again. So x times 2y dy dx plus second y squared times the derivative of x is 1, and then minus x cubed times the derivative of y is dy dx, and then minus y times x cubed times the derivative of x cubed, which is 3x squared. And then the derivative of 6 is 0. Okay, so I'm going to really quickly solve this for dy dx, which involves us subtracting y squared from both sides and adding this term to both sides, and then factoring out the dy dx and dividing. So we get dy dx is 3x squared y minus y squared all over 2xy minus x cubed. So that's the first step. It's just implicit, but it does have product rule in it, and then solving for dy dx. Okay, so we got that. Then next, we want to know where we have a vertical tangent line. So that's where the derivative, that's where the denominator is 0. So I want to know where this is 0. So I can factor out an x and get 2y minus x squared equals 0. I'm going to use the 0 product property, and I get x equals 0. Come on. And I get 2y minus x squared equals 0. Okay, so for the x equals 0 one, if I plug 0 into my original equation up here, I get 0 minus 0 equals 6. And 0 minus 0 doesn't equal 6, it equals 0. So this is an extraneous solution, and so it's not a solution. So the next, I got to go to this next one, and I have a y and an x. So what can I do with this? Well, I have two unknowns, okay? And so I need another equation. So here's one equation here, and here's a second equation up here in my intro, okay? So I need to solve one equation for one variable and plug it into the other one. Now, since my second equation in the introduction, everything's multiplied together, so I don't want to solve that. So I'm going to solve this equation number 1 for y. I add x squared to both sides, and I divide by 2, and I get this. And I'm going to substitute that in my original equation. So I'm going to have x times y is x squared over 2 squared. Again, I'm plugging this into, come on. Okay, now it's going to freeze. I'm going to plug it into my original equation in my prompt. Come on, guys. There we go. My original equation in my prompt up here, which I'm highlighting. Okay. Keep going. Minus x cubed times y, again, is x squared over 2. And that equals 6. So I multiply this out, and I get 1/4 x to the 5th, because x squared squared is x to the 4th times x is x to the 5th, and I also have to square the denominator. And then this is minus 1/2 x to the 5th equals 6. So these are both x to the 5th, so 1/4 minus 1/2 is negative 1/4 x to the 5th is 6. And then I'm going to go up to the top of the screen since I've run out of room. And so I get x to the 5th is negative 24. And then I take the 5th root of both sides. And I can take the 5th root of a negative number. So x is the 5th root of negative 24. Okay, not pretty, but there's my answer. Stop sharing, go back over here. Okay, I just wanted to share that with you since so many of you completely left it blank. Okay, guys, anytime, send me questions. I can work stuff out. I can make a video, or we can actually set up a time in the afternoon where I can work out problems. I hope you're doing well. Take care. Talk to you soon.